So, in the first hour we looked at solving equations, and we got into some pretty complicated ones. Next thing I want to do is I want to look at where do those equations come from? In other words, how do we take the words and translate them into the symbols? I've mentioned before that this is one of the most difficult concepts in math, is taking those words and putting them into the symbols. And we've talked a little bit about it. If I have a statement like a number decreased by 11, what's that going to be in symbols? X minus 11. The key there, this is subtraction, of course, is the decreased by. We might have a number split 3 ways. What's that going to be? Yeah, what's it going to be divided by? Yeah, x divided by 3 or x over 3, like that. Five less than a number. X minus 5. Good. The product of a number and 8. X times 8. Or we usually write it as just 8x. Put the 8 in front of it. 8x means 8 times x. This one's got a very subtle difference to it. We had the 5 less than a number up here, which was x minus 5. But this is just 4 less a number. It's 4 minus x. You got it. Well, this one we took a step further. A number increased by 2 is 9. What's been added into this one? What's extra here? The is 9. What does that mean? Something equals 9. Wherever that is the equal sign, and we have our sides on either side of that. So equals 9 is one side. What's on the other side? X plus 2, a number increased by 2. Good. How about this one? 7 times the sum of a number and 4 is 63. Well, I can always start with the equal sign. What's that? What's going to be on the left side or after the equal sign? 63. What's going to be in front of the equal sign? Okay, parentheses with the 7 in front. Good. 7 times the sum implies that we're doing the sum or the addition first. So we have the parentheses. So 7 times x plus 4 in the parentheses. Of course, that'll be different from 5 times the number increased by 2 is 57. What's that going to look like? Careful. Do we need parentheses in this one? This one was 5 times the sum. This one's just 5 times the number. 5x increased by 2, so plus 2 equals 57. Good. Now in my math lab, I'll warn you about this. I think I mentioned it before. When it does something like this, it'll tell you right down by the answer, use W for the unknown number, or P. Make sure you read that. So twice the sum of 7 and 3 times a number is 38. Find the number. What are we going to do? Twice is 2 times something, yes. Parentheses, because it's the sum. 7 plus 3x. 3 times a number, so 3x equals 38. Are we all done? It's asking us to find that number. So now what do we have to do? Distribute. 2 times 7 is 14, and then 2 times 3x is 6x, and then got to put a plus there because it's a positive 6x, good. It's 38, and then subtract 14, giving us 24 over here. 6x, and then divide by 6. X equals 4. Any questions? I'm going to have you guys try one. Try this one in your notes. We'll talk about it in a second. Okay, walk me through it. Nobody wants to be brave? We have the sum of something, right? Which means we're going to have parentheses of some kind. The sum of what? Okay. X plus 6, is it x plus 6? 2x, or twice a number. 2x plus 6, there we go. That was kind of subtle. Hello. What's up? Okay, so we've got the 2x, twice the number plus 6, in the parentheses. Now we've got the is here. Does that mean it's an equals? No, I put that on there on purpose. Is not always equals. What do we have to do now to that parentheses, the sum? Multiply by 5. Now we could put the times 5 on the back end if we wanted to, but for me, I like to keep things simple. We're used to seeing it in front, so let's keep it there so it doesn't confuse us. So that sum, this is the sum, is multiplied by 5. Then what? Equals 60. To get 60 means it equals 60. Then what? 5 times 2x. I didn't actually say find the number, but let's find it. So 5 times 2x is 10x. And then 5 times 6 is 30. Good. And then subtract 30 to get 10x equals 30. And divide by 10. X equals 3. Having fun yet? Yes? Good answer. Not so sure. Okay, well, the next step is to move up to problems that are a little bit more applicable. To do that, however, we've got to get through a couple of steps to get there. And the first step is to solve some really simple word problems and translate them into the symbols and the formulas. The problem with those is they're so simple that sometimes it's tough to translate them into the formulas because you look at the problem and you, after reading the problem, you know how to solve it. You don't need the equation to do it. So it can be a little bit tricky. For example, you might have let's see that you sell $3,381 worth of product. If each item is $23, how many did you sell? Well, I would look at this and I would see that I have to do what to find my answer? Divide. Yes. I have the total dollar amount. I'm just going to divide by the price per item to get the number of items. But a lot of times my math lab is going to ask you for your equation before it asks for the answer. So let's put this in an equation. There's a relationship between the price and the number sold. We have the number sold times the price equals the total money taken in, total dollars, I'm going to put it as. So in this case, what is it that I'm looking for? How many did I sell? The number sold. And that's one of the things we have to do in these. We have to look at what is it that we're looking for. And we have to try to make sure we define our variable to either be that or something that allows us to figure that out. In this case, the number sold is what we're going to define our variable to be. And it doesn't have to be X all the time. It can be any letter. To change it up, I'm going to use N. So we're going to let the number sold be N. What's the rest of this formula going to look like then? N times 23 equals 3,381. Now, just like that is perfectly fine. That is a beautiful equation. Works great. We could, however, if we wanted to, adjust this to be 23 times n, or 23n, equals 3,381. Either one of those is going to be solved doing the same thing, which will be dividing by 23. Good. Give us that n is what? 147. Yes. Or we might have shoot, I read this all right. Tim's pay is 20 times his weekly retirement savings. How much does he need to earn in a week? If he wants to save gotta be careful not to make this too unreasonable. $80. Now again, I would look at this, and to get the answer, I would do what? Just take $80 times 20 to get the pay, right? But this, we need to write out the formula. Tim's pay is 20 times his weekly retirement savings. So 20 times his savings equals his pay. Or we could say pay equals 20 times savings, either way. So we already have one of the numbers there, the 20. So either we have the savings or we have the pay. Which one do we have? We have the savings. We have $80. So 20 times 80 equals his pay. All we are going to do is multiply that out. 20 times 80 is $1,600. He needs to earn $1,600 that week if he wants to save 80. Any questions so far? Sometimes, now let's do one more. Let's say Tim's earnings are 4 times his income tax. How much is his tax if he earns $9,256? I'm going to have you guys try to come up with a formula for that. I don't want just the answer. I actually want the formula of the equation and then the answer. What was our formula? Well, 4 times something, right? 4 times what? 4 times his tax equals earnings. Good. So what is it that we're trying to find here? Tax or earnings? How much is his tax? So tax is going to be our variable. We can make it. Let's make it T. What the heck? So what's the rest of this going to look like? 4T, yep, equals, perfect. 4 times T, or 4T, equals 9,256. Divide by 4. So T equals, perfect, $2,314. Well, sometimes there's a formula that we can use for these. For example, because I just put in gross pay in here, is equal to hours times wage. Knowing that formula, we can look at, okay, at $12 per hour, how many hours need to be worked to earn $384? How are we going to put this together? Perfect. 384 is the gross pay, equals, they're asking how many hours, so I'm going to leave that as H or X or whatever, times the $12 per hour is the wage. Well then, how do we solve it? Divide by 12. Good. So the number of hours will be 32. You might have MPG, or miles per gallon, is equal to miles divided by gallons. So then we might have the question, at 26 miles per gallon, how many miles can you drive on 14 gallons of gas? Again, go ahead and set this one up and we'll go over it in a second. Okay, what's our formula going to look like? 26 equals miles times, or not miles times, miles over 14, divided by 14. Okay, now what are we going to do here? Multiply by 14. We divided by 14, we multiply by 14. So we get, what is it? 364. Perfect. Good. We might have a formula. Interest is equal to principal times your rate times your time divided by 100. Don't know why that line did that, but we'll fix it. So if $2,000 is invested for 3 years, what rate is required to earn $300 in interest? Talk me through it. $300 is I. Good. equals, do we know P? It's the amount of money we start with, principal. So that would be 2,000. Do we know R? R is the rate. That's what we're trying to look for. So we're going to put R in there as a variable. Do we know T for time? 3 years. So 3. And of course, this is over 100. Now, we have not solved an equation like this. What has happened here is of course, this being a fraction bar, everything on top happens first. So R was first multiplied by 2003. And then it was divided by the 100. So to solve it, the first thing we have to do is multiply by 100. That was the last thing done. So we get 30,000 equals 2,000 times R times 3. Now we could have actually done this as well, and we're going to do it right now. We can combine. 2,000 times 3 is 6,000. Then what? Divide by 6,000. R equals 5. So it's 5% would be the rate. For those of you going on to business math, by the way, I simplified this formula a little bit just to make it work so we didn't have to use decimals. Normally you wouldn't have the divided by 100 there. You just put the rate in as a decimal. So instead of 5, we would have got 0.05, and you have to move the decimal point to get a percent. But we haven't done percents or decimals yet, so I had to simplify the formula. Okay. Like I said before, that taking the words and putting it into an equation or an expression like that, a formula, is probably the toughest thing to do in math. And unfortunately, it's not something I can really sit here and teach you by showing you examples. The only way to really learn it is to do it, by working through doing a problem, trying to write that formula. And that is where my math lab really comes in handy for this topic, because it can step you through it if it needs to. So I'm not going to do any more examples of that. I'm going to let you do that in the homework. There are a couple of more things I do want to go over, however. From our order of operations, we talked about enclosing symbols, and we saw a couple of different forms. We saw the parentheses, we saw the fraction bar, and we saw even how a square root could have multiple numbers in it to become an enclosing symbol. But we're going to look at another one that looks like this. We may have mentioned this one before, but we didn't work with it really. It is called the absolute value. And it serves two purposes. Just like the square root symbol or the fraction bar, it's an enclosing symbol, so it separates parts of the problem, but it also has an action that's required with it. The absolute value means distance from 0 on a number line. So if I'm thinking about that, here's 0, and negative 8 is how far from 0? 8 units. So the absolute value of negative 8 is 8. What is the absolute value of 7? Careful. It's just 7 units. The distance will always be positive. Absolute value, so there's a little space between. The absolute value of a negative 3 is 3. Good. So like that, it's not real difficult to work with. But if we run into it like this, absolute value of a negative 5 minus 2. We must first perform, this is why we reviewed the integers earlier, first must perform that operation with the integers. What is negative 5 minus 2? Perfect. Negative 5 plus a negative 2, or negative 7. Absolute value of negative 7 is 7. So here we have the absolute value with stuff inside of it. What are we going to do? Well, inside the absolute value, inside the enclosing symbol, we still have to do order of operations. No other enclosing symbols. Any exponents? No. Multiplication or division? Multiplication. 4 times negative 3? Negative 12. And then 5 times negative 6 is a negative 30. And then this becomes negative 12 plus 30, which is negative 12, positive 30 is 18. Absolute value is 18. Cool. Don't get used to absolute values always being positive, though. It is possible to have a negative answer. For example, in this one, where do I start? Inside the absolute value. 7 minus 23, which is positive 7 minus 23 is negative 16. Very good. Now that I've reduced what's in the absolute value to a single number, I can do the absolute value and get rid of that symbol. So the absolute value of a negative 16 is positive 16, or just 16. The 3 was outside. The negative 3 was outside that with no operation, so it's going to be times. This is negative 3 times 16, which is negative 48. So even though there was an absolute value in that problem, the answer can still be negative. Do this one in your notes quick, and let's go over it in a second. Where are we going to start? Well, there's 2 enclosing symbols. There's more than one item on the same level. We always go left to right. So we're going to start with this one. Inside there, what do we have to do? 7 minus a negative 2 is 7 plus 2, or 9. Now that we've reduced that to a single number, we can get rid of the enclosing symbol to get, what's the absolute value of 9? 9. Good. Over here, what do we have to do? Negative 9 plus a negative 12 becomes negative 21. Now we still have to get rid of the absolute value. What does that become? Absolute value of negative 21 is 21. What's going to go in between here? It's still minus. Good. So now we have 9 minus 21 is negative 12. How many of you got negative 12? Good. That's promising. Cool. If I were asking you to compare numbers, what symbol would you put in between a 7 and 5? Greater than. Which way does that point? Like that. Perfect. It always points at the smaller number. Remember, we're asking if we put, this is asking if we put 7 and 5 on the number line, which side is the 7 on? Well, the 7's on this side of the number line. So that's the symbol we use. What symbol's going to go in here? Is negative 3 less than or greater than negative 12? It is greater than, because on the number line, here's negative 3, here's negative 12. Negative 3 is on this side of the negative 12. How about here? Less than. Because on the number line, here's negative 22, here's 3. Negative 22 is on this side, on the 3. How about this one? Greater than. How do we get that? Absolute value of negative 48 is 48. And 48 is greater than negative. A positive is always greater than a negative, right? How about this one? Less than. Good. Because again, this is a positive 25. 7 is less than 25. Any questions? Okay. Well, I've mumbled on long enough. There is a new quiz that is due tomorrow. That's Friday at 11:59 p.m. There's also a new homework that is due next Tuesday at class time. Here in Rice Lake, I will have the lab open down the hall if you want to use it. I'm in Richmond. If you want to use the computer lab, I will be in this room until, I will be popping back in and out of this room at least until at least 5:20. So if you want to work on stuff for about 10 or 12 minutes, you can, and you are free to ask me questions. I'll be around. Actually, I think the network stays up till 5:25, so I'll be here till then.